Hello everyone. So today we will start a new subject, thermodynamics. So in thermodynamics we will basically start with the definition. What is thermodynamics? So we describe thermodynamics as a branch of science which deals with energy interaction and its effect on the system and surrounding. So in the definition there are basically the few points which we should remember. So let me mention those points first. So first is it deals with energy interaction. So first point you should remember is energy interaction. The second is its effect on what? On system and surrounding. So next we will see what is system and what is surrounding. So let's start with system. So excuse me. So system is a mass or region which is under observation, that or which in mass or region in which our space our study is focused. Or we can also describe system as as it is described in books, like system is a finite quantity of matter or finite quantity of matter or prescribed region of space. Next we will talk about what is surrounding, as we discussed earlier. So discussing the surrounding, so what surrounding mean is everything except the system is called surrounding, or in other language we can describe surrounding as everything external to the system is called surrounding. Now there is another term which is called immediate surrounding. Let me take some light color. Immediate surrounding. So what is immediate surrounding? So we can describe it as part of surrounding, which is part of surrounding which is directly affected by a system system. Okay, so there is another term called boundary, and this is the important term. So now the question is, what is boundary? So boundary is a real or imaginary? Boundary is a real or imaginary envelope that encloses the system. The system encloses the system, and it is called boundary of the system. Like this boundary may be fixed. So let's write it may be fixed or movable. Okay, so boundary may be real or imaginary. And what is boundary? Real or imaginary that develops the envelope the that. So what is boundary? Boundary is real or imaginary envelope that encloses the system. It may be fixed or movable. Okay, so the next thing is like we will draw a diagram for and define what is system, what is surrounding. So let's draw a diagram. So let's say that this is the area, this is the area under observation or under study region of space where we are where our study is focused. So this part is called system. Okay, now this boundary, this boundary, this line that, or we may call it the surface that envelops the system is called boundary, and everything outside the system is called surrounding. Okay, so this is the basic definition of system, surrounding, and boundary. Next we can like see more example. First let's draw a cylinder piston arrangement. Okay, just give me a minute. A cylinder piston arrangement. So let's say this is a cylinder, and inside it we will draw a piston. Okay, so this is the piston. So in cylinder piston arrangement, what happens, that cylinder and piston moves, sorry, a cylinder remain fixed, but piston moves up and down. So let's say at a particular moment of time, this is the location of piston, and so here what will be our boundary? So let's say this part is the boundary, and here the boundary is real. Okay, but what happens next when this piston moves downward? Piston moves downward, the region of space which it encloses also increases, so our system size increases. So from here we can see that the system boundary may be fixed or movable. Okay, so this is basically system boundary. The white line indicates the system boundary, or we can simply write it as boundary. Okay, and next we can also like so let's see here what happens if the cylinder or piston is not closed like open system. Let me define it here. Okay, so here what we have done, so let's say that here the valve is open, like if there is a valve there. So let there is a valve. So if the valve is open, or there is a hole in cylinder, so what will happen when the piston moves? This system, like this total area is a part of system, but what will happen when that's the piston moves, like say upward, then this part will get deformed, like the air will exit from there, so it will come, like say like it like this when piston moves upward. So here we can see that this boundary, the system boundary we have drawn here, it is imaginary, let's say. So it is imaginary boundary, and this was the real boundary. Here it is the real boundary. Okay, so the next step is to study the types of system, like so we will see here types of system. There are basically three types of system. The first one is closed, second is open, the third one is isolated. So here we will see what is a closed system, what is an open system, and what is an isolated system. Okay, so let's start with the closed system. So if the boundary of the system is let's talk in the term of energy interaction and mass interaction. So let's say that give me a minute, make an adjustment. So here we forgot the one thing, and that is energy interaction. Let's talk about the energy interaction first. So what is energy interaction? So energy interaction, like the term interaction represent, it is a like transfer of energy between system and surrounding. Okay, transfer energy between system and surrounding. It is interaction between system and surrounding. Okay, and the interaction is happening through energy. So there is a similar term, mass interaction. Mass interaction is interaction of mass between system and surrounding, again system and surrounding. Okay, so here when we talk about the type of system, like closed system, open system, and isolated system, it is basically defined with the help of let's say energy interaction, and mass interaction. Okay, so let's draw a table here. So let's see here. So in closed system there is energy interaction, that is the energy, there will be interaction of energy between system and surrounding, heat. So let me clear make a thing clear here. The energy, like the heat and work are type of energy interaction. Okay, we will study in detail further. Okay. So there is energy interaction and mass. There is energy interaction in closed system. But since the system is closed, there will be no mass interaction between system and surrounding. Okay, and for open system, let's say there is an energy interaction and also mass interaction. We can see the example of like this is the example of closed system. So there will be transfer of sorry there will be a transfer of energy from system and surrounding, between system and surrounding. But this is the open but there will be no mass transfer. Okay, mass cannot be transfer. Okay, but in this case of open system, there will be transfer of energy and also there will be transfer of mass. I mean, mass interaction will be there. Okay, so in open system there is both energy interaction and mass interaction. For isolated system, there is neither energy interaction nor mass interaction. So we will next see some example of energy of open, closed, and isolated system. So let's talk about the closed system. For closed system, we can say is first thing is piston cylinder arrangement. Piston cylinder arrangement without valves. Okay. And the second point is lid closed water bottle, like we keep our water bottles in the fridge. So what happens that its lid is closed, but still the water cools down. So that is type of energy interaction. Okay, there is energy interaction, but there is no mass interaction. No water from the bottle is missing. Okay, let's talk about the open system. Okay, the first thing is piston cylinder. Again, piston cylinder, here it's with valves. Okay, since there will be valves, so they will open and close, and subsequently they will cause the transfer of energy and mass simultaneously. Okay, the second example we can these famous things you have heard, like nozzle, turbine, okay, etc. Like these things, they are called open system. Okay, so in the case of isolated system, we can you have to remember these two examples. They are frequently asked in some examination. That is thermoflask, and the second is the most important is universe. So next, let me talk about what is universe. Okay, so what is universe? Universe is the total system plus surrounding is called universe. Okay, so system and surrounding combined is called system and surrounding combined is called universe. Okay, so this whole section will be called universe. Now except these three, there are as we discussed, closed, open, and isolated system. There are few more type of system, and these terms are not frequently used, but when it is asked or when it is used in question, I think you all should know. So I will just mention that. So one is adiabatic system. So adiabatic system is a type of closed system, but what happens here? Adiabatic system is type of closed system what happens that the walls of like if we insulate the wall of the cylinder, what will happen? They in terms of energy interaction, the there will be no heat interaction, no, but there will be energy interaction. Okay, energy, I mean, in terms of heat, sorry, work interaction, there will be work interaction. For adiabatic system, there is no heat interaction, but there is work interaction with the surrounding. Okay, and and if we say that there is no work transfer, if we say there is no work transfer, then what this becomes? This becomes a isolated system. Okay. Okay. Next thing is homogeneous system. Homogeneous system. Okay. So what is homogeneous system? uh, Homogeneous system consists of of single phase. Okay, phase. And if a system consists of single phase, like say, what is a phase? A phase is a quantity of matter which is homogeneous throughout in chemical composition and physical structure. Like if I say there is a system which contains to entirety of oxygen. Okay, so this will be called homogeneous system. A system which contains entirety of water, liquid water, so this will be called a homogeneous system. Okay, now there is another term. Since there is homogeneous, there is ought to be a heterogeneous system. And what is heterogeneous system? Heterogeneous system, if a system consists of two or more, let's say two or more phases, it's called heterogeneous system. So we can also see some examples for homogeneous. Here its example, we can say mixture of air plus water vapor, or the second example we can talk about water plus nitric acid. So these are some example of homogeneous system. The second example of heterogeneous system, we can talk about water plus steam. Water plus steam, there will be two phases here. First one is liquid and the second one is gaseous. Okay, and the second is ice plus water, solid and liquid. Okay, or we can also like take water plus oil, since chemical composition is not same throughout. It will be also a heterogeneous system. Okay, now it comes the most important, let's say most important point of the thermodynamics. It is generally asked in many interviews or examination. What is macroscopic and microscopic point of view? Okay, so we will discuss first, let's say macroscopic. So in macroscopic, macro mean big. Okay, and or total, we can also say total. Both are the meaning of macro. And as in case of microscopic, micro means small. Okay, so if we talk about the definition, so in macroscopic, so what we do in, let's write it here. In macroscopic, we are concerned about average behavior, of molecule rather than their individual behavior. Okay, and in case of microscopic we can describe as we are concerned about individual we are concerned about individual behavior of molecules rather than their average behavior. Okay, so this macroscopic requires simple mathematics formula, we can say. And this since in case of microscopic, the system behavior is found like system behavior is concerned is due to individual molecular behavior. So we have to use statistical method. Okay, so here we use statistical method to study, and here we use simple mathematic formulae. Let's say simple formula. Okay, next like the if we talk about like let's say example, if we talk about the sample of gas in a closed container, then the pressure of the gas is the average value of the pressure exerted by the individuals. Okay, individual molecules. And similarly, temperature is also the average value of translation kinetic energy of the molecules. Okay, next if you also talk about like velocity, momentum, and impulse or the kinetic energy of the system, kinetic energy, so these will be described with the help of individual molecules. Okay, so this will come under microscopic observations, microscopic point of view. Okay, next, so in case of macroscopic, we can describe the whole system with only a few properties. Okay, we can use properties to describe the state of system, to describe the system. But in case of microscopic, since there are large number of variables like velocity, momentum, due to individual but individual molecules, there will be a large number of variables. So this approach is complicated. Okay, and a large number of variables are used to describe the system property, the system. Okay, next let's talk about continuum. So from macroscopic point of approach, we came to a continuum theory. Okay, or we can talk continuum later. Let's first discuss the properties of system. Okay, or let's first discuss the thermodynamic equilibrium. Okay, it is also an important topic. Thermodynamic equilibrium. So a system is said to be said to attain a state of thermodynamic equilibrium if it follows three types of equilibrium state. Okay, so the first one is thermal equilibrium. Okay, the second is mechanical equilibrium. Mechanical equilibrium. And the third is chemical equilibrium. Chemical equilibrium. So only if all these three equilibriums are satisfied, then only the system can be said to have in thermodynamic equilibrium. So the thermal equilibrium refers to the temperature of the system. Temperature. Okay, so the temperature at each and every point of system should be same. The second, mechanical equilibrium is used to refer there will be no unbalanced force. There will be no unbalanced force within the system or between the surrounding. Okay, and it can also be referred like the second, the pressure of system is same in system is same at all points, and that no changes time. Okay, the third is chemical equilibrium. So in case of chemical equilibrium, we can say there should not be no, I mean there should not be any chemical reaction. Okay, so no chemical reaction should take place, okay, in the system. Okay, and the chemical composition must be throughout the system, does not vary with time. Okay, next we can talk about the properties of system. Okay, so first question is, what is property of the system? So property of system is characteristics. It can be described as the characteristics of system. Okay, property is the characteristic of the system. So okay, and this characteristic system depend upon the state, and uh, so uh, uh, what we studied here is the property of the system is basically the characteristic of the system, and this property is classified into two parts. First one is intensive intensive property, or it can be, it is also mentioned in intrinsic property. And the second one is extensive or extrinsic properties. So here we should either use intensive, extensive, or I mean either you should we should use the term intensive, extensive, or intrinsic, extrinsic. Okay, you should not like mismatch this intensive or extrinsic or something like this. Next, what is intensive properties? So intensive properties are the properties which do not depend on the mass of system. On mass of the system. Okay. So their example. Let's talk about the example. Like temperature, we can talk about temperature of the system. So temperature is irrespective to the mass of the system. Okay, temperature at every point of the system will be same. Okay, and then next we can talk about the pressure. Okay, so pressure is also a intensive property. Okay, next for extensive properties, let's so the extensive properties are the properties which depends upon mass, on the mass of system. Okay, so example for extensive properties are like we can see all those terms which are dependent upon mass. So let's talk about the volume. Volume is dependent upon mass. Okay, so if we decrease the volume, the mass will decrease. Okay, so volume, there is energy, total internal energy. Okay, there is entropy, total entropy. Okay, and in case of intensive, we can talk about specific volume. Okay, is specific internal energy. Okay, or specific enthalpy. We can also talk about the enthalpy. Further, specific heat capacity, small c. Okay, and heat capacity, capital C, which is termed as mass into small c. Okay, so these are intensive properties, these are extensive properties. Okay, so what we can if like say if you are mentioning any property and asked whether this property is intensive or extensive, what we have to do, it's a simple thing. First you have to draw a system, like this is a system. So what, and imagine what will happen if I divide this system into two parts. Okay, let's say if I have it is asked for property like V, volume. So if you are asked the volume is extensive or intensive, so let's say the total volume of this system is capital V. Okay, and if you but if you divide it into two part, like this will be V1 volume, this will be V2 volume. So this is extensive property. Okay, let's say if I talk about temperature. Okay, so when you say about talk about temperature, so the temperature at this point and this point, there will no effect after dividing system, so it is an intensive property. Okay, next let's talk about pressure. Okay, so pressure, when we talk about pressure, so the pressure at this point or this point, both will be same. There is no difference on dividing system. Okay, so pressure is also an intensive property. Okay, let's talk about the energy of system, or let's say more about, so let's talk about okay, so energy, total energy of system. Okay, if we talk about total energy of system, what will happen if we divide system into two, the energy will be also divided into two parts, E1 and E2. Okay, so this is extensive property. Okay, so in similar way we can you can describe any property as intensive or extensive using this same approach. Okay, next we will move on to the next topic. So so let's talk about state of the system. Okay, state of the system. Okay, so what is state of the system? State is a condition of the system. It describes the condition of a system, condition system at an instant of time, at any instant of time, at any instant of time. Okay. State of the system is a unique condition of the system. So state is the unique condition. Let's mention it is important point. It is a unique condition of the system. Of system. So what the unique condition of system means? It means that this cannot the condition of system at two states cannot be same. Okay, if there are two different states, then their condition will also be different. Okay. Next, next we will discuss about as we discussed till now, the state of the system is the condition of system at any instant of time. Okay, so this state of system is defined or defined using properties of system, defined by properties of system of okay. And from this we can say that if any property of the system, okay, so if any property of system changes, its state will also change. Okay, like say if we decrease or increase the pressure, so like pressure is the property of system. Okay, so if we increase or decrease the property of the value of pressure, then its state will also change. Okay, and this change in state is called. So let's talk about the next topic, process. Okay, so the process is described by change of state. Okay, change in state. So this process that we call change in state. So whenever a system undergoes a change in state, or there is an energy transfer at a steady state, okay, so this will be called a process. So this process may be like we can talk about non-flow processes or flow processes, non-flow or flow processes. Okay, so non-flow process is where the mass is fixed. Okay, mass is fixed, or also closed system. Okay, so in case of closed system, there is non-flow process. In case of for flow process, the mass is we can say that mass is not fixed, or there will be a transfer of mass will be present there. Okay, transfer will be there, and this type of process occur for the open system. Okay, next we will talk about process path. Process path. Okay, so what is process path? So when a system changes states, when the state of system change from one point to another point, there are infinite number of points intermediate points between them. Okay, and when we the infinite states through which system passes, okay, while changing from point 1 or state 1 to state 2, is called the process path. Okay, so let me write the definition. while changing from state 1 to state 2 is called process path. Okay, so this process can be classified as quasi-static or non-quasi-static process, or reversible or irreversible. We will talk about this later. Okay, so let's talk about quasi-static and non-quasi-static process. Okay, so the first is quasi-static. Or the second is non-quasi-static. Okay, okay, so the quasi in the quasi-static means almost. Okay, so almost static process. Okay, so if the process occurs like in very slow manner, it will be called quasi-static. Like say let's take a cylinder piston arrangement in this case also. Wait a minute. Okay, okay, so let's talk about cylinder piston arrangement. So let's say this is the piston. Okay, so what we will do here is like we will release many small sand particles on there. Okay, we will drop sand particles continuously on this. So what will happen, the piston will, after a certain amount of a number of particles fall on the system. So let's say their particles are collecting. So the piston will start moving downward or in a very steady manner. Okay, so the movement of particle, if we draw a like PV diagram, pressure volume diagram, if we observe the pressure here and the volume of the system, so we can see here that like say this is, okay, let's say this is the initial point. There is the pressure P present and the volume V. Okay, then after adding like finite amount of sand, the pressure start moving. Okay, so this movement will be continuous. Okay, like continuous movement. So this continuous movement of the piston, it is in a very slow manner. Okay, so from, and after certain amount of time it reaches a state 2. Okay, so this continuous path which we obtain here, let me draw it again. This continuous path which we have gotten here from point 1 to 2 is called so this is the continuous path. And the process is non-quasi-static. So this is a quasi-static process. Okay, and if we talk about non-quasi-static, so let's move to a, like, I will copy these diagrams. Okay, copy and I'll paste it here. Okay, give me a moment. So here, okay, so here let's remove these lines, delete. Okay, so let's say the initial pressure of the system is P. Let me change the pen. Okay, let's do it on white. Okay, so what we do here, like we are is dropping or putting the small blocks of let's say sand. So here these are particle we are talking in terms of particle. Here we are talking like say 100 grams or 500 grams of gram weight we are continuously keeping on this piston. We are moving, like dropping one by one, putting it one by one. Okay, so first it will reach this state, let's say. Second it will reach this state, then this state. Okay, so at this is point 1, then it reaches here, then it reaches here, then it reaches here, then here, then here. Let's say this is the final position 2. Okay, so we can see that this path of the system is not continuous. Okay, so we can like describe it as dashed line or dashed point. Okay, so this path is not continuous. So this kind of process is called non-quasi-static process. Okay, so next is reversible process and irreversible process. Okay, so let's talk about the reversible process or irreversible. Here only we will talk about reversible process and then irreversible process. Okay, so here what we can like talk about is like say see, if we remove the sand particles from here, like if we start removing sand particles from here one by one. Okay, one particle by one particle we have started removing the particles. Okay, so if we remove the particle and the process from point 2 to point 1 follows the same line. Okay, same continuous line it follows from 2 to 1, from 1 to 2 process, and in backward it follows 2 to 1. If we remove the mass, then the process is called reversible. Okay, so what is reversible process? Reversible process is a process which can be reversed in direction following same path as of the forward path. Okay, without leaving any changes to system and surrounding Okay, so if so first thing we talk about it moving from 2 to 1 with on the same line, and the second condition is that it shouldn't like let me highlight it here. So follows the same path. Okay, and the second is leaves without leaving any changes to system and surrounding. Okay, so so it won't leave any change on the system and surrounding. So there shouldn't be any heat transfer, like this path from 2 to 1 shouldn't be received achieved with the help of heat transfer, transferring heat to the system, or adding work or removing work. Okay, then it will be called reversible process. Okay, otherwise it will be reversible. If this thing is not happening, then it is reversible. Okay, next we can talk about next in this we will talk about cycle. Okay, what is cycle? Okay, so any process or series of processes, this can be achieved in a single process or a combination of or series of processes. Okay, whose end state end state or states are identical identical is termed as cycle. Okay, so the process through which the system can system has passed can be shown. It can be shown by like we will draw a diagram. Okay, so let's say we are drawing a plot. So let's say this is pressure, this is volume axis, and there is a process, like there is a combination of processes. Let's say from point 1 to 2 we move, sorry, this is point 1 and 2. We moved from point 1 to 2, then from 2 we moved to point, let's say, point 3. Okay, and from 3 we moved back to point 1. So we can see that at start of the process it was at state 1, and at end of the all the series of processes it again returns to state 1. So this is called a cycle. Okay, so since there is cycle present, so there will be heat and work interaction, and we will talk about it later. Okay, here we will talk about point function and path functions. Okay, so point functions, let's start with the point function. So the when two properties are located when properties locate a point on a graph. Okay, so so these are called point functions. Let me draw a PV diagram. PV, so this is pressure axis, volume axis, pressure axis, and let's say we can indicate a volume of a system. Okay, let's say at a certain instant of time a system is as a at a pressure P1 and volume V1. Okay, so it will indicate this state of system. Okay, so when two properties locate a point on a graph, then those properties are called point function. Okay, so for point function we can write it as when two properties locate a point on a graph, then those properties are called point functions. Okay, so there are example of, let's talk about the examples are like, we can, first one is pressure, then we can also talk about temperature, volume, etc. These are all called point function. Okay, and we can like so if we talk about a small change in volume. Okay, so let's talk about dv. Okay, so if we integrate it between state 1 to state 2, we can directly obtain v2 minus v1, and this, my friend, is called exact differential. Okay, exact differential. Okay, and all the point functions are exact differential, and there's one more point: the point functions are independent of path history. Independent of path history. Okay, so from here you can see uh, it's directly v2 minus v1. So the change in volume is directly dependent upon the final and initial state. Okay, there is no requirement of what is the volume at any intermediate state, so it will be independent of any path history. Okay, next we can talk about the path functions. Okay, so what are path function? So let's say that there are certain quantities which cannot be located by a point on the graph. Okay, so they are either represented by the area on the they are represented by the area on the given graph. So these type of properties is called the path function. Okay, so let's talk about we will talk about some examples. So let's talk about the heat and work. Also, although we have not talked about what is heat and what is work, so let me clarify a few things first. So to describe heat and work, we can like first draw a PV diagram here. Okay, PV diagram. Okay, so if we talk about any process, let's say as we discussed earlier, we moved from point one to point two. Okay, so this process, so the we will study further that the area under this area is referred to work done during process, work done during process. ठीक है. So we can see from here that the path function like heat and work is is dependent upon path history, depends on path history. Okay, and the second point is that if we different integrate the small heat or small work, so from 1 to 2, this won't be equal to q2 minus q1. Okay, so the heat is from point heat transfer from or work done from point 1 to 2, we can also like is delta w from 1 to 2 is not equal to w2 minus w1, because work is a path function. It will depend upon the history of the path. Okay, from where it passes. If we draw different processes, then the area under the curve will vary. Okay, so the work done will vary, so it depends upon the path history. Okay, we can represent it as q12 or q from 1 to 2. Okay, for work done we can write it as for work done from 1 to 2 or work done from 1 to 2. Okay, so this delta sign here is used to represent the inexact differential. Okay, and here the term d is used to describe the exact differential. You should remember this. Okay, now we will talk about continuum. Okay, so earlier we talked about what is macroscopic or microscopic point of view. Okay, so now we will talk about continuum. It is a very important topic. So according to continuum, uh, matter can be treated as continuously distributed without any void being present. Okay, so The continuum approach is valid when we can treat the system as like there is no void present. Okay, so we assume the given system to have to follow the continuum approach when mean free path of the system is very less than system dimension. Okay,